Hello, and welcome to Snippets for Statistics. Today's lesson is on correlation. What is a correlation? Correlation is a statistical method for measuring and describing a relationship in terms of direction, form, and degree. Direction is the slope of the relationship, and it can be positive, negative, or zero. The form is the shape of the distribution, and the degree is the number or magnitude. Note that this can't be larger than 1. If it is -1, that's the smallest it can be. It has a negative slope, and it is a large, high degree. If it is +1, it's a positive slope and has a high degree of relationship. In order to calculate a Pearson R, which is the standard calculation for when we want to look at correlational data for integer or ratio data, and it's a linear relationship, we use the following formula. R equals SP over the square root of SSX times SSY. You will recall that SSX is simply the sum of squares for the X value, and SSY is the sum of squares for the Y value. SP is a new term and denotes the sum of products. We'll be learning more about that in just a few minutes, but it is essentially when you take the product of each X and Y point and you sum all of those and use the sum of basically a formula like the sum of squares, we get the sum of products. Again, we will step through this carefully. So here are the two formulas. This is for SSX and SSY. You'll note they are essentially the exact same formulas. The only difference is that SSX, we replace those with the X values. SSY, replace those with the Y values. For SP, we will take the sum of the products. Each X and Y value are multiplied, summed. Then we subtract out the sum of all the X values and the sum of all the Y values. Those are multiplied together in total, and we divide by n. So let's do an example. We're considering the following problem where we relate a student's reported anxiety rating to the student's exam score. Here's the raw data. We have 6 students. They each have an anxiety rating and each has an exam score. The criteria we'll use is alpha equals 0.05, and we'll look at it as a two-tailed test to see if there is a significant relationship between their anxiety rating and their exam score. What we want to calculate when we do our calculation will be sum of x, sum of y, sum of x squared, sum of y squared, and sum of x times y. So if we were going to go ahead and put the problem out that we want to understand the relationship between a student's anxiety, their self-reported anxiety rating, and their exam score, we might set it up like this. First, we'd state the hypothesis. Our null hypothesis is that rho equals 0. In this case, we're saying there is no relationship between anxiety and test score. Our alternative hypothesis is that rho does not equal 0, and that there is a relationship between anxiety and test score. We set our criteria, and it's given as alpha equals 0.05, and we're going to look at it two-tailed. We're not going to care if there's an increase or decrease. And then we'll collect our data. Certainly we've already seen the data, but we'll go ahead and create it in the time sequence. We'll go ahead and get that data now and put it out here. So now we have our 6 students, their anxiety ratings, and our exam score. One of the best ways to start a correlational problem is to graph the problem. We'll look at it graphically in a scattergram. Along the x-axis, we have the anxiety rating. Along the y-axis, we have the score for the exam. We plot each point that's given in the table as a single dot on this graph. Here we have the anxiety rating for student A, who has anxiety rating of 5, and exam score of 80. We will look at plots for each of the different students and see how they lay out in the graph. We can then look to see that the overall relationship appears to be a negative relationship, with higher exam scores relating to lower anxiety rating scores, and therefore higher anxiety rating scores relating to lower scores on the exam. This is interesting information and it's good descriptive data, but we want to determine if there's actually a relationship, which we'll need to calculate R, and then we want to understand if this is a statistically significant relationship. So we'll have to actually do a statistical test and take a look at our critical values, our obtained values, and relate them, compare them to our critical values. All right, so let's analyze the data. Here we have the entire table laid out. For each student, we are going to look at their anxiety rating in the X column, And we're going to sum those up just like we've done before and many times in the past. Get the sum of x, which is the sum of all those scores. We will then square that to get sum of x squared. In the second column, x squared, we've taken each x value and squared it. Then we've summed those squares up to get the sum of x squared, and that gives us 168. We do the exact same thing for the y values. Sum of y equals 498, and sum of that squared, the 498 squared, gives us 248,004. And we also have a y squared column, which is each y value squared and then summed. And at the bottom we have sum of y squared equals 41,406. The new column is the xy column, and that's where we take each x value, the x value for each person. For example, for A, we would take the value 5 and multiply it by their exam score. In this case, for person A, that's 80, and get the xy value of 400. 5 times 80 equals 400. We do that for each student, and then we sum those scores up to get sum of xy. The values we're going to need to get sum of products, sum of xy, sum of x, and sum of y, are calculated on this page. In addition, we know that n equals 6. Okay? We can take a look to see where we got those x and y values. So now we compute our sum of squares. So, as you know, SSX equals sum of x squared minus sum of x quantity squared over n. We replace the values and get 168 minus 900 over 6 gives us 18. Sum of squares y, same thing. We have the formula from the previous and the values from the previous table. We substitute, and we get SSY equals 72. Sum of products. Remember, we calculated sum of xy, that was the very last column, and then we subtract out the sum of x, just the individual x scores, and we multiply those by the sum of y, and then divide that by n to get the following values, and sum of products. Remember, sum of products can be negative or positive, so getting a negative number is not incorrect. In fact, this tells us that it's a negative direction, as we noted in the scattergram. Now we can calculate r. We use each of the individual values and go back to our formula where we said r equals sum of products over the square root of sum of squared x times sum of squared y. Let's substitute in those values. Negative 32 over the square root of 18 times 72 equals negative 0.88. This is a fairly strong negative relationship. But is it statistically significant? We need to do one more thing to determine that. We use the criteria, we looked that up, the critical value for R. Depending on what version of Gravitern law now, it might be table B6, the page number might be different, but this is for the critical value of R. We're going to use alpha equals 0.05 and look at a two-tailed test with n equals 6. So our degrees of freedom are n equals 2. In this case, when we do correlation, because each person has two values, and so we can set that as our degrees of freedom, n equals 2. So 6 minus 2 equals 4. So we're going to be using 4 for degrees of freedom in the table. When we look in the table, we see that the critical value is 0.811. Since our value for R obtained is 0.88, and that's more extreme than the critical value of 0.811, we can reject the null hypothesis and conclude that anxiety and exam scores are related. This concludes the snippet for statistics on correlation. Thank you very much.